In this video, I will introduce the basic theoretical ideas behind Clarion and its overall structure. If you had to quickly describe Clarion to somebody, say in an elevator, you might throw out the following ideas: that it's a connectionist symbolic hybrid architecture, that it exhibits a dual representational structure, that it addresses learning, skills, reasoning, motivation, metacognition, and social simulation, and that it consists of a number of distinct, interdependent, and complementary subsystems with complex interaction. These are some of the most distinctive features of Clarion, and they are motivated by various theoretical considerations. Clarion is informed by some fundamental ideas about how cognitive architectures should be designed. The first of these is the ecological functional perspective, which is simply the notion that a cognitive architecture should have some degree of ecological realism. The next idea is modularity, which is a general organizational principle. It states that the architecture should be divided into several components, where each component fulfills some specific function, more or less independently, and that the different components should communicate with each other in some limited way. The idea of modularity naturally motivates the multiplicity of representation. This is because different functions may be best served by different types of representation. Finally, the dynamic interaction of modules refers to the idea that modules should work together in order to fulfill the psychological function of the agent. In addition to these, Clarion is also built on two meta-principles: the completeness of functionalities and the parsimony of mechanisms. The idea here is that the architecture should account for a maximum range of phenomena using the smallest possible set of mechanisms. Clarion is designed to satisfy some more specific desiderata. The first of these desiderata are fairly straightforward, so I'll focus on the remaining 5. That is, on implicit versus explicit representation, synergistic interaction, bottom-up and top-down learning, procedural versus declarative processes, and motivational and metacognitive control. One of the most fundamental ideas in Clarion is the distinction between implicit and explicit knowledge. Implicit knowledge is tacit knowledge that's acquired outside of one's awareness. It's detected in a number of tasks, including artificial grammar learning, sequence learning, dynamic system control, and probability learning. Generally, it's associated with the following pattern of observation. On one hand, subjects are unable to report knowledge acquired during the task verbally, but on the other hand, if you test their knowledge by other means, they exhibit task knowledge. So the idea here is that they really are not aware of this knowledge. The reason this distinction is fundamental to Clarion is because it informs the most distinctive feature of the architecture, which is the dual representational structure. In Clarion, every subsystem can be divided into a top level, which encodes explicit knowledge, and a bottom level, which encodes implicit knowledge. These two levels interact. For example, they cooperate in action decision-making and in learning, and they may encode knowledge in a redundant way. Speaking of learning, Bottom-up learning is when knowledge is acquired in the top level based on knowledge already present in the bottom level. Likewise, top-down learning is when knowledge is acquired in the bottom level based on knowledge already present in the top level. This is essentially a dual process theory of the mind. One important feature of the interaction between the two levels is that it results in synergy. There is experimental evidence and simulated results showing that such an interaction may speed up skill learning, improve skill performance, facilitate transfer, enable similarity-based reasoning, and support creative problem solving. Beware, however, because it's easy to confound the implicit-explicit distinction with another, more familiar one, the procedural-declarative distinction. Implicit knowledge is often identified with procedural knowledge, and explicit knowledge with declarative knowledge. The two dichotomies are conceptually distinct, and Clarion takes this distinction very seriously, so they are captured by different mechanisms. One simple heuristic to remind you of the conceptual distinction is simply to say that implicit knowledge cannot be verbalized easily or directly, while explicit knowledge can. On the other hand, procedural knowledge simply supports action, while declarative knowledge supports retrieval and inference. From these descriptions, there's no reason to assume any kind of specific association between one branch of the first dichotomy with some branch of the second dichotomy. An important feature of Clarion that is motivated by the ecological functional perspective is its emphasis on motivation. According to the ecological functional perspective, we'd like to explain why an agent does what it does. Simply saying that an agent chooses actions to maximize gains, rewards, or reinforcements leaves open the question of what determines these things. So it basically shifts the question. It doesn't really answer it. In Clarion, motivation is captured by drives and their interaction. We postulate low-level primary drives that reflect biological needs, high-level primary drives that reflect social needs, and other secondary drives which are acquired. Finally, there's the issue of metacognition, which refers to one's knowledge concerning one's own cognitive processes and the control and regulation of these processes. In light of the concept of dynamic interaction, we'd like the different mechanisms, goals, and drives in an agent to function in a harmonious way. Some kind of mechanism is necessary to coordinate these different processes. In light of all these considerations, we arrive at the general structure of Clarion. The view from space is that you can think of Clarion as a network of neural networks. The component neural networks, the theory doesn't constrain much, but what it does is tell you how those networks connect to each other. A Clarion agent is divided into 4 subsystems, and each subsystem contains within it various other subdivisions. These subdivisions may have one or more neural networks. Let's start with the action-centered subsystem, which encodes procedural knowledge. This subsystem is charged with outputting action decisions. It has a dual representational structure where the top level encodes explicit action rules linking the current state to various actions. The bottom level, on the other hand, encodes reactive routines. Various forms of learning are available in the ACS, including reinforcement learning, where routines in the bottom level are incrementally adjusted in light of rewards and punishments. Bottom-up rule extraction, where implicit knowledge in the bottom level informs the formation of explicit knowledge in the top level. And top-down assimilation, where pre-existing rules in the top level guide and train reactive routines in the bottom level. The non-action-centered subsystem encodes declarative knowledge, and you can think of it as a query engine. It performs memory retrieval and various forms of inference. Within the non-action-centered subsystem, there's a further division between semantic and episodic memory. The NACS is directed by the ACS through various specialized internal actions, and it communicates with the ACS through working memory. Working memory in Clarion is not to be confused with the concept of working memory in cognitive psychology. This is because, in Clarion, working memory is an information store that simply facilitates communication between the ACS and the NACS. Any executive functions typically associated with working memory in cognitive psychology are performed by the ACS. Like the ACS, the NACS is also subject to various forms of learning. An important point to notice at this stage is how the implicit-explicit distinction and the procedural-declarative distinction are treated differently within the architecture. The implicit-explicit distinction is pervasive across all the subsystems, whereas the procedural-declarative distinction is simply captured by two separate subsystems. In that sense, the implicit-explicit distinction is more fundamental in Clarion. The motivational subsystem maintains motivational representations. In the top level, these are explicit goals, which may be set by the action-centered subsystem or by the metacognitive subsystem. On the other hand, drive activations, which are also called drive strengths, are determined by the motivational subsystem, and they determine the context in which goals and reinforcements are set. The metacognitive subsystem is dedicated to the monitoring and regulation of processing. It consists of several modules. Each of these modules fulfills a distinct metacognitive function, including behavioral aiming, which refers to the determination of reinforcements and goals, information filtering, which essentially refers to selective attention, information acquisition, which refers to selection among the various learning methods available to the different subsystems, cognitive modes, which determines which level dominates processing, and various other subsystem parameters. Otherwise, the processes and structure of the MCS is similar to that of the ACS, so it is primarily action-centered.